In this lesson, we are going to be solving rational equations, which means that we are solving equations that have fractions in them. These fractions may be numbers or contain variables. So, like we know with adding and subtracting, we need to find a common denominator. So it looks like with an x and a 2 and an x, our common denominator would be 2x. So we look like in the first fraction we're missing a 2, so we're going to multiply both top and bottom by 2, which would be 6. In the next expression we're missing an x, so we need to multiply the top and the bottom by x. In the next expression we're missing a 2, so we're going to multiply the top and the bottom by 2. Now, because we would have a common denominator of 2x, we do not need to worry about the denominator any longer. All we do is solve the equation using the numerators. So we'll subtract 6 from both sides. We have negative x is equal to 18. And then we divide by negative 1. And so x is equal to negative 18. And we have solved our equation. In the next example, we can see that we have a x plus 1, 4 is over 1, and we have an x plus 1. So it looks like we need a denominator of x plus 1. So on our second expression, we're going to multiply both the numerator and denominator by x plus 1. So we already have that. So we have 5x equals. Then we're going to multiply 4x and 4 and take away 5. So we have 5x equals 4x minus 1. Subtract 4x from both sides. And so we have x equals negative 1 as our solution. However, we can see that if we were to replace x with a negative 1, we'd have negative 1 plus 1, which would equal 0, and we cannot have 0 in the denominator of a fraction. So even though we solved this correctly, this is an extraneous solution, and so we would not have a solution on this one. All right, in our next example, we have factored. Okay, so it looks like in our first example, our first expression, we're missing an x plus 2. So we're going to multiply both the numerator and the denominator by x plus 2. And then in our second example, we're going to multiply both the numerator and the denominator by x plus 2 and x minus 2, so that we have a common denominator. Again, when we have a common denominator, we won't worry about using the denominator. Since it's common, we'll be able to just solve by using the numerator. So we'll FOIL the first. We have 3x squared. 3x times 2 is 6x. And we have negative 2 times x and negative 2 times 4. And then we know that x plus 2 and x minus 2, when we multiply these two together to FOIL, we already know that that's x squared minus 4. So we are going to bring everything over to one side. So we are going to combine these two together to get 2. And then we're going to subtract x squared from both sides. And we're going to minus 2. So we have 2x squared, combining like terms, plus 4x minus 6 equals 0. So the greatest common factor would be 2. X squared plus 2x minus 3 equals 0. We're going to make our factor tree. What two numbers multiply to be negative 3 but add up to be 2 would be 3 and negative 1. So we have 2, and then we have x plus 3 and x minus 1 equal to 0. So we're going to finish solving by setting these equal to 0. Okay, last step is to make sure that these will work in our equations. We have -3 and we have +1. So neither one of these will be a problem if we plug in for x to give us an extraneous solution. So in this case, both of these solutions will work, and we have two solutions to our equation. In the next example, if we have only two rational expressions equal to one another, it truly is a proportion. So we can solve by cross multiplying. So we're going to take 3 times x plus 4, and we're going to leave that in factored form. And then we're going to take x plus squared plus 4x times 1. And we're going to make sure to factor the denominator, which has a factor of x in common. And then we can simplify the x plus 4's, and our final answer will be, 3 over x. So please remember that when you're solving rational equations, you need to find the least common denominator, check for extraneous solutions, and cross multiply when each side of the equation is a single rational expression. So please try these two examples.